All right. Now we're going to talk about how to draw ionic bond diagrams. And what are ionic bond diagrams? They're otherwise known as Lewis diagrams. In your curriculum, you probably will see them as written as valence electron diagrams. And they're basically little diagrammic representation of a single bond that exists between two different ions. So let's get started. Now we're going to focus on doing the simplest of all ionic bonds, valence electron diagram, and it involves the combination of sodium and chlorine. Yes, sodium atom here has just that one valence electron. Now remember, there's always inner shell electrons, but we don't really care about that. We just want to focus on the valence electron. Okay? And chlorine here, so sodium here has one valence electron, and chlorine has 7 valence electrons on its outer shell. And so when these two atoms come together with enough force, they collide, and upon collision, sodium is going to give out, so they're going to come and collide, right? And when sodium collides with chlorine, sodium is going to donate the valence electron to chlorine. And so what happens is that sodium is now an ion, a sodium ion. And to do that in this ionic bond diagram, we write the symbol of sodium, followed by a bracket on the outside, and we need to indicate the charge of that ion. And because sodium lost one electron, so that means it has one extra proton compared to electron, it now has a positive charge. And so you need to write the symbol, write the brackets, and also the charge. Okay? And you would do the same thing now for chlorine. Now because sodium has lost its valence electron, we don't draw any of the inner shell electrons now. Now, in reality, sodium ion now is energetically stable because inside here there is a full noble gas configuration. And we're not going to draw that because that's just not how it's represented. All right. For chlorine, it has accepted that electron from sodium, and now it becomes an ion too, and its ion is now called chloride. And so we have this symbol for chloride. It has the original 7 valence electrons around it. Oh, I'm sorry. Sometimes in IGCSE they love to draw these little circles around there. No, I don't, because it's just a waste of time. But that's how your curriculum goes about it. And so you have the original 7 electrons for chlorine, and because you added another electron from that was given by sodium, it's now become a chloride. And so it's an ion. And to represent that it's an ion, you draw the brackets as well. Okay? You draw the brackets. And what's the charge of this chloride? Well, it has 1 less protons compared to electrons, so it has a negative charge. Negative charge by how much? 1 negative charge. But we don't write the ones in diagrammic or formulaic form or format. And so this here will now be the valence electron diagram for sodium chloride. Alright? Sodium chloride. And we will learn how to write names and formulas for ionic compounds just a little later. So there we go. Now let's look at a different set of elements. And this is group 2 as well as the oxygen group, which is oxygen. Here I have magnesium and oxygen. Magnesium has 2 valence electrons and oxygen has 6 valence electrons. And when they both come together and collide with each other with enough force, you will notice that because magnesium has 2 valence electrons, in order to achieve a noble gas configuration, it can either lose 2 electrons or gain 6 extra electrons. It turns out losing the 2 electrons is energetically more efficient, or less energy is required to lose the 2 electrons than to gain 6 electrons. And so it's going to lose the 2 electrons, and who's going to lose it out to? Because it collided with oxygen, oxygen is now going to accept those 2 electrons. Because oxygen has 6 valence electrons, it can either achieve noble gas configuration by losing all 6 electrons or gaining 2 extra electrons. It takes less energy to gain 2 extra electrons, so that is what oxygen is going to do. So magnesium gave its valence electrons to oxygen. Magnesium is now an ion. Yes, magnesium is an ion. It has no more valence electrons out on the previously outer shell, and now it's an ion. And to illustrate that, we draw the bracket. And what's the charge of this magnesium ion? Well, it has 2 extra protons compared to electrons, because magnesium did give away 2 electrons, so it is now a 2+ charged ion. What about oxygen? Well, oxygen now originally had 6 valence electrons, okay, and it received 2 of the electrons from magnesium, and so now it's become charged. So we represent that by drawing the brackets. And how much was the charge of this oxide now? The oxide, which is the ion of oxygen, well, it has 2 extra electrons, so electrons carries a negative charge, so the charge of this oxide is a 2-. And so when these 2 comes together and you draw it out like that, that is what we understand as the valence electron diagrammic representation of this ionic compound known as magnesium oxide. All right, let's talk about what happens if we change it up a little bit, okay? Let's change this up a little bit. I'm going to wipe this clean. Yeah. Shouldn't really use my hand now, it's like dirty, but it's okay. It's no big deal. Let's talk about using a group 1 element combined with, let's say, a group 6 element. Okay. Now, these are not very common elements as in the curriculum, but it's okay. All right. Okay. Lithium and sulfur. Lithium group 1 valence electron. It's going to lose it when it collides with sulfur. Sulfur has 6 valence electrons, willing to accept 2 extra electrons. Oh, so lithium has 1 valence electron. It can only give out 1, but sulfur needs 2 valence electrons to achieve noble gas configuration. So what gives? Well, okay. It turns out because sulfur needs to accept 2 valence electrons, it's gonna need another lithium. Basically, you're gonna need another lithium to achieve that. Okay. All right. So these things are gonna collide with each other in a proper orientation. Now, I did not draw this in the proper orientation, but it does not matter. Assuming that the geometric orientation in which those particles collide is perfect. All right. So when they collide in perfect orientation. Lithium is going to give out these electrons to sulfur, and lithium now is going to form, there's two lithiums, right? It's going to form an ion. There we go, form an ion, and each of this lithium ion is a +1, right? Sulfur, on the other hand, gain the 2 electrons from lithium. On top of that, its own 6 valence electrons. And now it's formed an ion. And the charge of sulfur, the charge of sulfide is now -2. And so the name of this is called lithium sulfide. Okay? What about if we change it up a little bit again? Let's do that. Let's say I have calcium and bromide. Okay? And now this circle ain't perfect like I originally had it, but get the picture, it don't matter. So calcium has 2 valence electrons, bromine has 7, and what you're going to see is that calcium can give out 2 electrons, bromine can only accept 1, so we actually need another bromine. Alright? Alright. So what's going to happen when they collide? Calcium is going to give 1 electron to this bromine up here and another electron to the other bromine down there. And when they come together to form ions, calcium ion is now going to be written like this, right? 2 plus, because we lost 2 electrons. Bromine, yeah, there's 2 of them now. There's 2 bromines. And I'm going to wipe this off because I need the space. Draw a little circle because that's how your curriculum does it. Draw the original valence electrons in, and that electron from calcium. Now you may ask me, I'm only draw 1 blue dot, but whoa, the reality is there's 2 bromines for every 1 calcium. Okay? And so ultimately when you form, the element now is called calcium bromide. Alright, but the real thing is that what you have to pay attention to is that the charge from the cation, or the causative ion, has to neutralize the charges of the anion, or the negative ion. 2 plus, 2 multiplied by a negative charge, that means gives it a 2 minus charge, and a 2 plus charge. These charges cancel each other out, and so what you have here, this compound, is electrically neutral. So when you touch salt, this calcium bromide salt, you will get electrocuted. Ha! Ain't that cool?